Hello, geometers. It's Ms. Backfish. I am here to talk to you about getting started with similarities, specifically looking at similar polygons. And I want to fill in some notes here that I have given you. And you'll notice that this format is one I like to use. I like to use the materials from this particular person who makes these. And I'm not going to name her in this particular video because there is one thing about this whole set of notes that I disagree with her on. Okay, now let's just go ahead and talk about what similarity means. Polygons with the same shape. There's actually two things. I just found another. But different sizes. It's not necessarily that they have to be different sizes. Basically, they're not necessarily the same size. Okay? If things have the same shape and size, that's congruent. If things have the same shape but not necessarily the same size, and usually not the same size, but not necessarily the same, is more accurate, because technically, if things are congruent, they are also similar. If they have the same size, then they are also similar, and we'll talk about why in a second. But most of the time when we talk about similarity, we're not talking about things that have the same size. We're talking about things that have the same shape, but different sizes. All right, what does it take to be similar? All the angles are congruent. That's what makes them the same shape. All the side lengths, or all the lengths, are proportional, not congruent, not the same, but proportional. Okay, let me give you a generic example. These two polygons, these two rectangles, are a very straightforward example of similar shapes. Okay, they're proportional, the side lengths are proportional, and we're going to assume that these are rectangles. So all of the angles are the same, they're all right angles. But the side lengths are proportional, meaning, and we could say it a few different ways. We could say 3/6 is the same as 5/10. Another way to look at it that also shows they're proportional is I could say 3/5 is the same as 6/10. Okay, so two different ways to look at the fact that my side lengths are proportional. Okay, a proportion is when two ratios are equal. So just using proportions, I can say true statements about the side lengths. Now, here's the big thing where I disagree with the way this is stated on this worksheet, and we're going to hit this a few times. I still felt like it was worth using it because I like these examples, but the ratio of corresponding sides is called the similarity ratio. Okay? And we're going to skip this for right now. Now, this is where the issue is. She doesn't use the word similarity ratio. She uses scale factor. Now, here's why I'm going to say similarity ratio instead. Scale factor is something that we reserve for dilations. If I do a dilation, an enlargement or a reduction, making something bigger to smaller, smaller to bigger, there's a scale factor involved. But when we say scale factor, we are always talking about a specific order. And you don't necessarily have to know this right now. We're going to come back to this. But scale factor is always the new length over the old length. If I'm looking at two similar triangles or two similar rectangles, there's not a new and an old because one of them didn't come from the other. We're not talking about a dilation. I just got two shapes in front of me. Okay? So with similar polygons, there's a similarity ratio, and really it could go either way. So I need to be asked which way. This is correct to ask me which way. It says, what is the, we're going to say that similarity ratio instead of scale factor of, and then it tells me the order. Something to something always means this one goes on top. The first one goes on top of the bottom one. All right, so I'm going to pick two sides that seem to go together, A, B, D, E. 8, 12. 8 to 12, and I can simplify that to 2 to 3. We always simplify if we can. So that's the similarity ratio of ABC to DEF. What is the similarity ratio? I'm going to say SR for similarity ratio of DEF to ABC. The first one always goes on top. So this time, and I could use the same two, I could use 12 and 8, but let's use a different one. 21 and 14. 21 to 14, it should give me the reciprocal of this, which it does, 3 to 2. So what these ratios tell me is that every single side length here, if I'm going from the smaller to bigger, it would be a 2 to 3 ratio. 2 over 3 is 8 over 12. 2 over 3 is 10 over 15. 2 over 3 is 14 over 21. If I'm going from bigger to smaller, it would be a 3 over 2 ratio. What about the ratios of the perimeters? Well, that's what we missed up here. If polygons are similar, then their perimeters are also proportional in the same proportion, the same ratio as their side lengths. So the ratio of the perimeter of, and now we have to look at the order, they're talking bigger to smaller would be the same as the sides, bigger to smaller, it would be 3 to 2. So let's test that. Let's add up 12 plus 15 plus 21. That gives me a perimeter of 48. And up here, 8 plus 10 plus 14, that gives me a perimeter of 32. Okay, so the question is bigger to smaller, because that's the order that was asked. Is 48 over 32 3 over 2? Well, how do we reduce fractions? We find something that goes into both top and bottom, and in this case, that would be 16. This is 3 times 16. This is 2 times 16. So yes, that's a 3 to 2 ratio. So the ratios of the perimeters, or the ratio of the perimeters, is exactly the same as the side length ratio, which we call the similarity ratio. All right, next up, a valid similarity statement must match corresponding angles and sides, just like a congruent statement. It looks just like a congruent statement. And order matters because it tells me which things correspond, which things go together. Write a similarity statement for the triangles above. Okay, triangle ABC is similar to triangle DEF. If you're not sure about the order, here they're marked, the angles are marked, so I can go with the angles that go together. Now, how do I say they're similar? Here's the symbol for similar. It's just a single squiggly. Looks like that. It goes up first and then down. So that is a similarity statement for the triangles above. All right, so below here it says directions. List all congruent angles and write a proportion that relates the corresponding sides. Okay, so JKL is similar to PMN. I'm going to mark according to this. J goes with P. K goes with M. L goes with N. Now it's going to make it easier for me to see what goes with each other. So angle J is congruent to angle P. Notice they're congruent, not just, we don't say that the angles are similar. The angles actually have to be the exact same, so they're congruent. All right, angle K goes with angle M. So those are congruent. And angle L goes with angle N, so those are congruent. Now the sides. This is actually called a statement of proportionality, what I'm about to write here. You don't really need to know that, but that's what it's called, a statement of proportionality, where I pick a side length over here. Let's say JK. First letter, second letter, that goes with PM. So I'm going to say JK over PM is the same ratio as, and then I'm going to write two others that go together. So KL goes with MN. So that would be the same ratio. And JL would be the same as PN. Okay, so that's what I'm being asked to do right here. Okay, why don't you go ahead and try number 2. Pause your video if you need to. And then I'm going to jump in and show you what I got. You ready to go on? Hopefully you've paused and written it out for yourself. Again, I'm going to mark the ones that go together. X goes with R, Y goes with itself, and S goes with Z. So X is congruent to R, Y is congruent to itself, and angle S is congruent to angle Z. Now, as for the proportionality of the sides, X, Y, I could completely ignore the picture and just do it from up here. X, Y goes with R, Y. And whatever ratio that is, XY over RY, is the same ratio as YZ over YS. And that's the same ratio as XZ over RS. All right, I'm not going to do number 3 for you, but you should do number 3. So go ahead and pause and do number 3 now. Moving on, we can use the ratio, the similarity ratio, not scale factor, okay? We can use our similarity ratio to find missing side lengths, okay? If the figures are below are similar with a similarity ratio of 2 to 3. Now, they didn't tell me, but I think they're assuming that I can look at the figures. They're assuming that I can tell something about the size from the figures, which is not the safest assumption because we're not supposed to assume size from just looking. But because they didn't tell me, based on the sizes that I see and based on the fact that we read from left to right, I'm going to assume they mean the similarity ratio from left to right is 2 to 3. So from here to here is 2 to 3. Really, they should be more specific, but they didn't. That's okay. So side lengths over here over side lengths on this one are 2 to 3. So that means 2 over 3 equals 42 over x. And I've just written a proportion, which is the whole idea of proportionality. How do we solve a proportion? Cross multiply. Okay, so 2 times x equals 3 times 42. 3 times 42, I did not already do. Let's see, that's 126. If I get any of these wrong in my head, you're going to have to tell me so I can go back and correct it. And this is what I get for x. All right, let's look at number 6. If triangle ABC is proportional to triangle DEF, find the value of x. So you do have to be very intentional, very deliberate about knowing which side goes with which. AB has x. And they say that AB goes with DE, so that goes with 25. X over 25 equals BC is 28, and BC goes with EF, so that's 20. So when I cross multiply here, I get 20 times x equals, and I'm going to have to grab a calculator. Okay, I got 700 when I cross multiplied. Then I can divide both sides by 20, and I get that x is 35. Notice that I have skipped 5 and 7. That's because I want you to do them. So on this page, which we're going to say is page 2, you need to do 5 and 7 and 3, basically the odds. Moving on. Uh-oh, sorry. I thought I had the pages out of order and I thought I was paused and so I was looking through it, but we are good. Okay, on this one, let's look at DEF is similar to HJG. Find the values of x and y. Okay, so my first challenge here is to find ones that I know go together. So let's see what goes with DE. Goes with HJ. Okay, so I have a fraction I can build my other proportions off of. I need to know both members of at least one fraction. Okay, if you wanted to, you could simplify this. This is 3/5 and use 3/5 when you set up the other proportions instead of using 9/15. You can only do one proportion at a time though. So for instance, let's say I want to do EF. That goes with JG. So that means I'm finding Y first. And again, I could have said 3/5 equals 14 over y. I didn't, but that's okay. So this gives me 9 times y equals 210. Then I divide both sides by 9, and I get y equals, I get 23.3 repeating for y. Now I'm going to go back and I'm going to set up a proportion to find x. And I could say 9 over 15 equals, x is GH, so that goes with FD, so that's 12. 9 over 15 equals x over 12. But I'm going to simplify the 9 over 15 and say 3 over 5 equals x over 12. It'll just make it a little easier to do in my head. So 5x equals 36. Still going to get a decimal. That's going to be 7.2. So there are my answers for number 8. Guess who's doing number 9? You got it. All right, let's look at number 10. If you want to, pause and do it now, or you can come back to it. Number 10 says if AGM, triangle AGM, is similar to triangle KXD, find the value of x. Okay, so AG goes with KX. So 32 goes with x over 3, x plus 3. And MG, 36, goes with XD. That's x plus 6. So when I cross multiply, I get 32 times x plus 6 equals 36 times x plus 3. And I'm going to get to distribute. So 32x plus 32 times 6 is 192 equals 36x plus 36 times 3 is 108. So I'll get 4x over here, 84 over here, and I believe x is 21. Okay. Again, guess who's doing number 11? I don't think it's a hard guess, is it? Okay, last one we're doing together. It says if BNV is similar to BRG, BR is 4x plus 7, and BG is 18, find the value of x. Okay, well, the only place I see the x is in BR, so let's find out what BR goes with. BR goes with BN. BN is 12. So 12 over 4x plus 7 is the smaller one over the bigger one. Keep track of what you're doing. BG is the bigger one. It's the side of the big triangle, BG. First letter, last letter. So BV is 8. So that's going to be 8 over 18. Everything is about what goes together here. So I get 8 times 4x plus 7 equals 12 times 18, which is 194 maybe? No, I think it's 206. Let's just actually use a calculator instead of our brains. 216. All right, there we go. 216. Then I'm going to divide both sides by 8 instead of distributing. You could distribute there, or just divide both sides by 8, and you get 4x plus 7 equals 27. 4x is 20, and x is 5. All of these seem to just ask me for the value of x, except this one. This one does ask me to go back and plug in. Okay? Now, I'm going to show you the answers to all the ones I said you were doing, which is basically all the odds to this point. All right? So if you haven't done them yet, go ahead and pause, go back and do them, and then check your answers. And then after that, this is page 3. Your homework are the 2 pages that start with this. Okay, it says more practice with similar figures. We'll call that page 4. And the next page we'll call page 5 that starts with number 7 at the top. Okay, so if you are not done with the odd problems, go ahead and finish those first. If you haven't done your odd problems yet, last chance, turn back now. All right, here's what you should have gotten. For number 3, everything in here. Number 5, this shows the work and the answer. And number 7, there's your work and your answer. Doesn't show quite as much of the work. Okay, here's number 9. Notice that I found a pair of sides that went together and then I reduced because I thought that would make it easier to do the rest of them. So instead of setting up my proportions with 40/16, I did 5/2 each time. Okay, and that's what you should get. And lastly, number 11, I'm going to do this one for you because it's important. Just like up here, you have to throw in these parentheses when you're trying to multiply a number times the entire denominator or the entire numerator, and you've got more than one term. So in other words, I've got 10 times all of 4x minus 1. Not just the 10 times the 4x, the 10 is times all of it. And I have 25 times all of x plus 5. So I have to distribute. And if you didn't get this one right, that could be a very common thing for you to have missed. So let's see, 15x equals 135. Divide both sides by 15. And I think that's 9. Now, we weren't just asked for x here, we were asked for the length ly. So that's 4x minus 1. So I'm going to have 4 times 9 minus 1. That's 36 minus 1. 35 is my answer for number 11. Okay, and you go ahead and complete this page and the one after it. And I will either post the key or we might wait and go over it Thursday. See you then.